Okay, here we go. Section 9.2, test for proportions. Two-tailed or two-sided tests. Why are they called two-sided tests? Well, let's talk about one-tailed or one-sided tests too. So buckle up. Here we go. What we did before, if the hypotheses were set up this way, the null hypothesis was that p equaled something, and if the alternate hypothesis was that p was greater than something, we looked at the tail on the normal curve that was greater than whatever. If this had been a less than, we would have looked at this tail down here. Greater than or less than tells you which tail we're looking at. It's pointing at the tail we're going to look at. Two-tailed or two-sided tests are a little bit less specific, I would say. This one is about a kid that reads something that says 50% of high school students have never smoked. Taeyeon wonders if that's true at his school. He's not saying, gosh, I think it's higher at my school, or gee, I think it's lower. He just says, I wonder if it really is 50%. So he says he's going to take an SRS of 150 kids. He asks them, 90 say they've never smoked. Good for those 90. What should he conclude? Okay, so we're going to walk through the whole thing, and we'll talk about what's different in terms of a two-tailed or two-sided test, and I'll show you on your calculator again. So I will talk about Darren's calculations, but I won't ask you to do them. So the state portion. We're going to perform a significance test using these hypotheses. The null hypothesis, fine. I think it really is 50%, 0.5. The alternate hypothesis, Taeyeon isn't saying, I think it's greater or I think it's less. He just says, I wonder if it really is that. And so his hypothesis is maybe P isn't equal 0.5, where P is the actual proportion of students who have never smoked. In our state, we say our alpha, our line where we decide later if the P is low or not, before we start, he's saying that's going to be at 5%. The plan portion, that's your conditions, as always. Randomness, it was stated. Normality, n times p and n times 1 minus p are both bigger than 10, so it should be approximately normal. Independence, well, we asked 150 kids. How many kids go to Taeyeon's high school? What's the population? We don't know that, but this sentence here says, it seems reasonable to assume there are at least 1,500 students in a large high school. I don't know if that's really true or not, but we're telling our reader that we're basing our calculations on that assumption. The independence, the 10% condition, same as always. Again, I'm going to point out, in proportions, the central limit theorem is never a factor. Normality for proportions, n times p and n times 1 minus p. So here's what Darren did. Here's the do. And again, we can gloss over this a little bit, but I want you to have an idea. Taeyeon got 90 out of 150. That's 0.6. Well, 0.6 would have a z-score, 0.6 minus 0.5. That's a little above what I would have expected. The standard deviation, square root of p times 1 minus p over n equals this. That score of 0.6 is 2.45 standard deviations above the mean. If this was a one-tailed test, I would find out this shaded green area and be done. Now it's saying what we have to do, though, is we go, well, all we were wondering is if it's not equal to that. What's our chance of getting a sample, like ours was 0.6, this far out here or this far down here? So in Darren's calculations, he looks it up in table A, and then he doubles it because there are two tails. Pause. Okay, so to do that on your calculator, we would go to Stat, scoot over to Tests. It's still a one-prop z-test. We still only took one proportion. Remember, Taeyeon asked 150 kids and 90 said yes to his question? It's still a one-prop z-test. When we get over here, p sub 0, that's the proportion in the null hypothesis. That's 0.5. How many kids said yes? 90. How many kids did he ask? 150. Now, today I'm going to actually do this wrong the first time on purpose and show you one thing here. What we really want is because our alternate hypothesis is not equal to, we would want to be here. Because from yesterday, I had it on greater than. If I forgot to switch it, it would say, when I go to draw, it would say, oh look, this is the situation. That 0.6 that Taeyeon got is 2.4495 standard deviations above the mean. That has a p-value of 0.0072. But it's only one tail. This would have been if our alternate hypothesis was that it's greater than. But our alternate hypothesis was that it was not equal to. So, back to tests. Scoot down to one prop z-test. Go down here, click. What I really meant was the alternate hypothesis is that the true proportion isn't equal to what I set up here. It's something different. Now when I click draw, the calculator knows that I mean both of these tails. It's still 2.4495, and this is negative 2.4495. That's the test statistic. But notice this p-value is now double. It used to be 0.07 something. Now it's 0.0143. 007. Now it's 0.0143. Okay? It's almost 1.5%. This p-value, the likelihood that I would get a sample that's that far away from what I expected at 0.5 is 1.43%. So what are we going to do with that p-value? Okay, great. We've got a p-value of 0.0142, about 1.42%. So now you ask yourself, is that p-value low? Well, 1.42%, is that a low number? Say, well, it is compared to 5%, and since at the beginning we said our alpha was going to be 0.05, we are comparing our p-value against 0.05. And if you compare 1.42% against 5%, this p is low. And if the p is low, we need to do one thing. If the p is low, we reject the null hypothesis and we say, I have evidence in favor of the alternate hypothesis that p really isn't 0.5. As Darren says it here, since our p-value is low compared to 0.05, we have evidence to reject the null hypothesis and conclude that the proportion in Taeyeon school who say they have never smoked is different from the national result. We have evidence in support of the alternate hypothesis. That's what's going on in a two-tailed test. The only difference is this is a not equal to. The alternate hypothesis is a not equal to. It says, I don't know if it's higher or lower. I'm just suspicious that it's something other than what was stated in the null hypothesis. Frankly, it's better if you can do a one-tailed test, because that's where you're saying, I'm suspicious that it's higher. I'm suspicious that it's lower. This is less specific. I'm saying, I'm suspicious. I just don't know which direction. I just think it's not that. A two-tailed test is, I think, less informative, which is why we'll get back into confidence intervals a little bit in the next video, and just for a couple questions on the A and B quizzes. But that's it for two-tailed tests.